for everyone. So yeah, now let's start. Fancy TypeScript features. We have with us Josh Goldberg, which is actually a front-end developer at Code Academy, to introduce us to this world. Or I don't know how introductory this course will be, Josh. But in any case, I understand that there are some very interesting features that an everyday developer could use. So please feel free. I will close my camera. I had internet problems the whole day today. I don't know what's wrong with it, with my internet connection. So I will switch off my camera and microphone. If anyone wants to ask anything, type it. I will monitor the chat and I will pass it on to Josh at the end. So thank you very much, Josh. I will stop sharing my screen and the virtual stage is yours.
Well, thank you very much. Hello, everyone. I have never been to mainland Europe, so I'm sorry to not say hello in person, but I'm very much looking forward to chatting with you all. I'm also going to be monitoring the Zoom chat, so please do ask any questions. Just to confirm, can everyone see my VS Code screen over Zoom? Someone could say yes in the chat. That would be wonderful. Or no. Yay! Thanks,
Yes.
Cassie. Awesome, glorious, super. So hello, I'm Josh. I'm from New York, the state of New York in the USA. I'm a very big fan of TypeScript. I hope that if some of you aren't yet fans of TypeScript, by the end of this talk, you might end up being. I work at a company called Code Academy, which has a few people such as Cassie here as well. So hi, coworkers. We're in New York. We teach people how to code. We're actually coming out with a TypeScript course later this fall at the intro level. So definitely look out for that and get excited. Let me know if you want free pro membership. I'd definitely be happy to exchange it for some feedback on the site. The goal of the talk today is to explore TypeScript features. I think not a lot of folks truly understand how absurdly useful TypeScript can be for getting your development flow more productive. TypeScript's very good at both describing your types of your JavaScript code and telling you where you go wrong. So I'm going to start today with the basics, really go over like what is a type, how does that work, and then get more advanced until we can't anymore. Everything is going to be given with examples of real code that you might write that then uses the type system. And at the end, we'll have a big snippet that we can share out and I'll post on Twitter and then in the Meetup org group thing site, so that if you want, you can go back and refer to these. So to start, I want to show off a couple of really great websites, although I'll be working in a VS Code window locally. One is the TypeScript website. It's got this, oops, spoilers. It's got this playground. So if you go to typescriptland.org and select playground, it's this great little place where you can try out different versions of TypeScript. On the left here, you can see the code that you might write in TypeScript. And on the right, you can see the equivalent JavaScript, the definitions, so what TypeScript thinks is happening in your code, which we'll go into later. And then you can also select what version of TypeScript you want. For today's talk, I'm going to be going into the nightly, meaning the most recent version of TypeScript that hasn't even been released on NPM under stable yet. So things might break horribly, in which case we'll have to go back down to 4.0. But nightly is cool and exciting, has some great features that I'm really excited to show you all. Another great site to look at is astexplorer.net. I would definitely recommend checking this out. By default, they go to JavaScript and then one of these other parsers, but I'm selecting the TypeScript parser. An AST, or abstract syntax tree, a little zoom in. Cool, let me know if you need more and I'm happy to. Thanks for messaging, Nash. AST, or abstract syntax tree, is a general description of how your code is structured. It's a tree form, meaning you have a root node with children nodes, each of which have other nodes. And each node is some section of your text. So I'm going to hide a bunch of useless stuff here. We can see in this file that let's say that we have const text equals ABC123. In here we have a variable statement, which contains a list of variables of size 1, one declaration, which has a name and an initializer. So if you ever see some piece of TypeScript code that you're not familiar with, let's say you see some function, and you're like, what on earth does that mean? I have no idea what that does. You can go to this site, astexplorer.net, click on the place and see that, oh, it's something called a type predicate. And then if you look up TypeScript type predicate in your favorite search engine, you can find the results online. This is great because there are lots of pieces of TypeScript syntax that aren't super familiar to people from other paradigms. There's stuff that's unfamiliar to C# developers, unfamiliar to JavaScript. So I definitely highly recommend if you ever see something, paste it into the Explorer to see what it comes out to on the right for JavaScript, and or ASD Explorer to see what it's actually called in TypeScript land. All right, moving on. I'm going to play in VS Code today. I'm going to set up a series of little examples, and then we'll dive in for each example into how TypeScript can be useful. The first little example is this piece of code, which takes in an input and logs the input. Now, it's just human beings looking at this code. We can't really tell what the type of input is. If we see a few places where it's used, we might be able to infer that, let's say it's a string in this case, or a number. The big premise of TypeScript is that if you say, oh, it's only ever a string, in your code, you can annotate it with this little type declaration saying the input is of type string. And this tells TypeScript that your function has a parameter, in this case, one input, that can only ever receive string. And if you were to call it with something other than string, it'd complain because TypeScript knows input is supposed to be of type string. And here we're passing 1, 2, 3 a number, which is why if you ever see this error message, number is not assignable to type string, you know that because this is inferred to be number, because this is a number 1, 2, 3, and the input is string, that's a mismatch. So the first feature I want to go over today is a union type, where sometimes you know in TypeScript a parameter or a variable or some other thing can be one of two possible types, or 3 or more. In this case, let's say that we want to be able to take in a string or a number for this function. The way you do that is with this type operator, or the OR operator in the type system. It's saying that this input type is of string or number, which I suppose is the way TypeScript sorts internally, so I guess I'll put it that way. Cool. Here we're saying we know it's not, let's say, a Boolean, true, because it can only be string or number. Boolean is not a string or number, but we know it can be string or number. It can be either of these things. So that's a union type. Now, this is useful because of something called, among other things, the $1 billion mistake. Curious how many of you have heard of this thing so far. Back in the day, many languages started off with the theory that you can assign null to any variable. Let's say that you have something that's a text string, and then you want to later on say like function receives text, which takes in text of type string and logs the text. Pardon me, my phone's ringing. This, in many languages, is totally okay, where we receives text the text, because we've said that the text is a string, and then we pass in the string. But you and I, as human beings, can look at this and say, well, text doesn't receive an initial value. So if we were to do something like log the text length, then this is going to crash. This is going to crash with some JavaScript error, like error cannot read property length of undefined. So the $1 billion mistake refers to one of the people who originally set it up so that you could pass the equivalent of null or nil or undefined to variables. They said that, okay, I guess this is fine. And then they estimated that at least $1 billion of damage have been caused by people not checking if text is undefined, throw new error cannot be null. So if you ever do those interview programs where like they ask you to write some like Java or C# code and you get points deducted for not writing some statement like this, throw new argument error, you can blame the $1 billion mistake. But in our code, we know that text is going to be string or undefined. So here we can now say that if the text is string or undefined, then TypeScript as the type system understands that it can be either of these things rather than just string. And switching over to the TypeScript playground here, this is useful because TypeScript has a config option called strict null checks, where it does not consider, pardon me, I'll just copy and paste this stuff over. It does not consider any particular value, let's say string, to be undefined or null unless it's explicitly allowed. Here we're saying text is used before being assigned because we know that text is supposed to be a string but isn't defined yet. So if we say that text is a string and undefined, then TypeScript is going to tell us undefined is not assignable to type string. Same with null, which is a key feature that I'm under the impression C# and other .NET frameworks recently received, or other .NET languages have either already started off with or only recently got. Which brings us to another feature called type narrowing, where if we forgot to put in the if text is undefined check here, and then we told the type system that text can be string or undefined, then TypeScript is smart enough when we have this strict null checks option to tell us that the object is possibly undefined. Because again, if we passed in undefined here instead of the actual text, then this would be undefined and that would crash. We're going to have to do if text isn't undefined, console log collect. And only if text is undefined do we log some default thing like, oh no, you forgot. Oh no. This is called type narrowing, where TypeScript can take a look at your conditionals, let's say your if statements, and understand that the only way the contents of this thing are going to be hit is if text is a string. Because TypeScript knows going into this function, text is either string or undefined. Therefore, if text is string or undefined, and text also is not undefined, then inside this thing can only ever be a string. TypeScript is able to narrow the type, meaning given a specific list of types, it narrows down which one it could possibly be. Similarly, inside this else statement, TypeScript knows that text must be undefined because text is either a string or undefined, and this is the else of text being not undefined. So here, text is undefined. So this is a really useful piece of code, this billion-dollar mistake fixer, this type narrowing, because there are a lot of places in code where it's very easy to accidentally pass something that might not be defined. In our code here, we're pretty sure that, okay, we know text is going to be a string in this case. But if you have the result of a function and the function most of the time returns a string, it's easy to mistake things. So TypeScript's able to come in here and help us out and tell us, no, you specifically need to check for it in this case because it might not be defined. By the way, if y'all would like me to speed up or slow down, please do mention in the chat. And if there are any things you'd like me to clarify, I would be happy to. So I'll just let this code snippet be visible for another few seconds, then we'll move on to some more advanced narrowing. I got one of these like big fancy water jugs, would highly recommend for work at home. All right. Let's move on to something called discriminated unions. This is not an HR nightmare. This is a legitimate TypeScript feature. Oh, almost forgot to zoom in. Let's say that you have a result from a function call, and it's either a successful result or a failure result. And let's say that if the result succeeded, there is some .text member, which is a string. And if the result failed, there's an error member with an error type. In a typical programming languages, let's say C# with an interface or TypeScript with an interface or type, you'd say like my text results would be like succeeded, Boolean, text, string, error, error. But this type isn't super duper accurate because the result is really one of two possible types. We know that if succeeded is true, then there's going to be a text but no error. And if succeeded is false, let's say that there's no text but there is an error. Now you might want to try to do something like a result string or error, or you could do something fancier, which is called a discriminated type or discriminated union. And even if you did do, by the way, this result string or error, you still need a way of saying that result is a string only if succeeded is true, and result is an error only if succeeded is false. So let's say that we have these two types here, and then we say that the result is either failure text result or success data result. And let's call this success text result. Now, this is a more accurate representation of our types for this theoretical potential API. If the API returns a failure, then we know that the succeeded is the false primitive and has an error. And if it succeeds, then it has a text result. Ultimately, we could say that result is error and text is, or part of the result is string in these two cases, but I like having different names for the things. Now here, TypeScript isn't giving us any complaints because we're able to apply narrowing again. We see that if result.succeeded is true, then the result is definitely of type success text result. And the reason TypeScript is able to infer this is because result can only be one of two possible types. It's either the failure or the success. It's a union of those two types, an either or. And if result.succeeded is true, then within that union, TypeScript can deduce, it can narrow that it must be this one, success text result. Because succeeded true is a more specific form than succeeded Boolean. So here, result is, oops, that's a horrible typo. Result is definitely success text results. And in this one, in the else, because succeeded must be false, result.error exists and result is failure text results. And if we mess this up, if we forget to check whether result.succeeded is true, and we try to do results.anything, TypeScript knows that the only possible member that we can guarantee at this point exists is succeeded. And if we try to do, let's say, result.error or result.text, we see the red squigglies because property text doesn't exist on the whole union. We don't know that it's not a failure, so it might not exist yet. Woo, TypeScript. So this is a very common pattern in super duper TypeScript code bases for integrating with APIs, where if you don't know whether the API is going to return a success, you might say in the type system, I'm not sure which is going to be the result of it, which means the type system can inform the way you type your code. It tells you you need to handle these things, even if you're not sure or might have forgotten to set that up for yourself. So yay, TypeScript. At this point, you might be noting, well, this is all useful and great, but my APIs return different types of data. Error is maybe always an error, but text is going to be maybe a string, maybe an object, maybe some other thing, a Boolean or complex shape. Which brings us to another topic of generic types. We can say in the type system that if we know text is going to be a string, it's always a string. But if we want some other type, let's say this data type, which is different for each version, then we can pass in this generic type to the objects. Oh, great question. Can more than two alternatives be handled? Yeah, totally. We could have a like configuration results. And then we might do like, actually, I'll type out elsewhere. The question was, can more than two alternatives be handled here? Yeah, totally. We could have like a status 0, which is a result happy. We could have a results unhappy with a status 1. And then we could do like results very unhappy with multiple errors. And TypeScript can understand any number of these things arbitrarily. So let's say I love live coding. I'm always nervous about typos. If result.status is 0, so if result was a success, then we can return. And in this point, TypeScript can narrow down to just result.status is either 1 or 3. I guess 1 or 2 makes more sense. Here, result.status is 1 or 2. And if we really want, we can, let's say, change error to errors and then very unhappy true and very unhappy false. So now the TypeScript type narrowing can understand that if result status is 1 or 2, and therefore the result is one of these two types, then we know that result dot very unhappy is a Boolean because it's either true or false. And result dot error is, let's say, either an error single or an error array. So if we change this to error array, then we know that error is just error. So yeah, discriminated unions can be super useful. Other places you might see them are actually in ASTs, where a node might be one of a bajillion different types of nodes. Maybe it's a text or an identifier or some such. So these are very useful and come up in a lot of places. Cool. Moving on, back to the success results. For a generic type, a generic is saying that a type can have one of any possible number of things, but we want to specify what the value is at a particular usage. So let's say like a type, my text success results is a success result of, let's say string. So here, if we receive my text, we know that result.text is a string because the data here infers as string because TypeScript says that the data is string in this particular usage. So we can actually map out a whole discriminated type union here, where the failure result, let's say, is an error and the success result takes in a data. And then if we have our handle result here, then we can have either a failure result in the general case or a success result with some data in it. Cool. So let's just let that sink in for a little bit, where the handle result takes in this data generic. And then the result is either the generic with the data or a general failure result. And again, pausing here if you have any questions you'd like to ask. This is very similar to the generics you might see in another programming language, such as Java, which was the question. Java, C#, other languages like that are a little different from TypeScript in that TypeScript generics are only ever understood at development time, similar with the rest of the type system. You can see on the right all these fancy types we're making here, this string or number, this discriminated union stuff, my text result. None of this actually gets output in JavaScript because the key tenet of TypeScript is that the TypeScript code gets compiled to JavaScript and any sort of TypeScript specific things like types or declarations, type annotations get removed. So C# and Java can actually access the generics at, I believe, runtime because they have a whole framework they're operating on and they can do operations on them. TypeScript, it's more of a conceptual generic. It's an, I'd like to imagine such a thing exists. Would this be correct? Type of phrasing. Let me know if that's not actually the question you wanted to ask. Cool. Moving on, key of types. I would like to posit a question to you. Suppose you have a function that looks like this, a getter. Yay. And the getter takes in a container and a key on that container and returns the value under the container of that key. This might look familiar to you if you ever used the library Lodash. Lodash has a get method, which is a much more complex version of this, and we'll have to work our way up to that. But for now, let's just use this thing, this little get here. We can tell that the container using our generic types is probably this container type. And the key, syntax is fun when you use reserved names such as get. The key is probably some kind of maybe like string or number. But this doesn't give us a lot of type safety because if we do my get on, let's say like name Josh and then key blah, that, I mean, that technically compiles. But what we really wanted to do was say that the key is specifically one of the keys of this container type. TypeScript actually has a thing for this called a key of type, where there's this key of operator in the type system, key of container, and it takes in a type and gives back the result of all the types that could exist. So if we say this blah thing is not assignable to parameter of type name, that's because TypeScript knows that my get given this object with just the name property can only ever receive a key of name. That's not allowed. What if we do name Josh, happy, true, and then try to type out? We can even see in TypeScript, it's giving us this nice little development time helper here where the key is either name or happy, which is a pretty sweet development time helper, I gotta say. this is one of the key tenets of TypeScript here, one of the key why you would use this over JavaScript. In addition to forcing you to type things out, right? It also gives you nice little helpers at development time. Cool. Moving on. We have key of types, which is taking in a type and giving you back the keys of it. Now let's talk about something called tuple types. If any of you are React developers, you might have seen code like this somewhere. I'm sorry, I'm receiving a call. Give me one moment. Cool. So this type here takes in an inputs, and for each input, if it's an error, adds it to the errors array, and if success, adds it to the successes array. So using generics here, let's say that the inputs is of type input or, pardon me, the function is of generic type input. I'm just going to correct my syntax to use the easier general functions. And then each input is either an input or an error, which means we know that these errors are an error array or these successes are a input array. Cool. This is how you declare an array type in TypeScript, by the way, for those who have not done that yet. All right, so this is an example, again, of type narrowing, where for each input, where the input is either an input or an error, we know that the input, if it's an error, must be error type. And if input is not an error, then it must be whatever our generic input was. But this function here returns a specific array of size 2, where the first member is an error array, and the second member is an input array. So if we do results equals split errors on, let's say, new error, oh no, and happy, TypeScript is able to infer that this function takes in a generic of type string. So the inputs are either string or error. But TypeScript thinks that the result here is an array of error array or string array. And that's because we haven't told TypeScript anything about this array being permanent or read-only or anything. We've told TypeScript it's an array and that the members are one error array or input array. But like we could do this. Array. So what we really want here is to tell TypeScript that we want to be able to do, instead of flexible operations on the result, we want to be able to say that const errors successes equals split errors on the result here. Let's just copy that over. Now, right now, again, TypeScript doesn't know anything more specific about these because, again, TypeScript understands that this is an array that has mutation operations, .push. But if we specifically tell TypeScript that this function returns a tuple type, which is an array of a fixed size with known members of it, and that tuple type has first an error array in it, then a successes array, or rather an input array. Here we can see that errors is in fact an error array, and successes is in fact a string array in this case, which is great. This is how the typings for React operations like use state and use other hooks work if you have ever used such a thing. Cool beans. Giving this a couple seconds to sink in. If there are no questions, we can move on. All right, moving on. Let's talk about type predicates, another cool feature of the type system. Let's say that you have a more advanced version of this function. Let's say you have inputs, which are an unknown type, which is the way of us telling TypeScript, I have no idea what this is. And you want to be able to split the inputs into fruits and vegetables and others, where the fruits are a fruit array, which is this type. So we can type out fruit array. The vegetables are a veggie type, which is another array type we can type out. And the others, we don't really know what they are. So we'll put that as unknown. Okay. Now we know this happens to return fruit, veggie, and unknown as a tuple type, which is a tuple type of length 3. But we need a way of telling the TypeScript type system that if an input passes this is fruit function, it is in fact an input of type fruit. And right now in TypeScript, we don't know what the input is. We see that we call is fruit input, but TypeScript isn't smart enough by default intentionally to be able to say that if something passes this as fruit, then it is this fruit type. So what we can do is we say the input is returned as input is fruit. This is us telling the TypeScript type system that if this function is fruit returns true, then that signifies that not only did the function return true, the Boolean, that the input was a particular type, this type predicate that we saw earlier. A predicate is another way of saying logically, for this, if something else is intended to be true, then this is true. So here we can see that if is fruit input passes, then the input is type fruit, because on line 168, we said that input is fruit when this function returns true. Similarly, for is veggie, we can say input is veggie. Why is this complaining? Oh, I've got a syntax error. I'm missing the parentheses. There we go. Now within this if conditional, the input is type veggie. And otherwise, if the input is still unknown, then we have others.push input, which is on type unknown. Cool. So to recap, a type predicate is us telling the type system that when a function returns true, it also indicates that an input is of a particular type. And here we can use it to split these inputs into a fixed size array, which is known to be const fruits, veggies, and others of particular sizes. Where fruits here, oops, that needs to be an array. Fruits here is of type fruit array. Remember, kids, eat your veggies. All right. Moving on. I want to talk to you about something called a mapped type. Let's say that you have a function that takes in a whole bunch of overrides and applies them on top of defaults, where your defaults might be some very basic things. Doesn't really matter what they are. And then the overrides are a particular object of that same type. Let's say that overrides is this props type. So again, going into the React land, this might be a function that generates the generic props for a function component. So what we want to be able to say is that override defaults takes in any amount of these props and then applies them on top of some defaults. But the problem here is if we just call override defaults with one of them, say emphasis now needs to be true instead of false, it's saying that this isn't valid because this one little object doesn't have all the props types that it needs. It's missing text, some other stuff. We could do a cast, which is a little cute syntax for telling TypeScript, shut up, I know what I'm doing. This is definitely the type that I think it is. It's not the type you think it is. But that's a little dangerous because we could add in other things and the cast. Oops. Oh, pardon me, they changed that. Ignore me. It's a little dangerous because an as removes information from the type system. It tells TypeScript, stop caring about what I'm doing. This is definitely correct, which is not always true. There are ways to mess it up. So what we really want to be able to say is that what we want for this props type is a partial. We want some of these things. So we could declare our own type partial props. And for each of these, we can make it optional, which would then work. That's kind of fine. But that's kind of a pain in the butt. Like who wants to do that? What we really need is some sort of type system operation where we take the original partial type or the original props type and we say partial of props. Now, lucky for us, TypeScript actually ships with this feature. You can't go to definition in the playground, so I'm just gonna, someone asked, don't you have to cast when you have an unknown type? Yes. If you have an unknown type and you want to say like function is fruits input unknown, if input as fruits dot type equals fruit. Yeah, like this would be one use case of having an as cast. Good question. And then otherwise return false. Let me just shove this up near the fruit stuff. Yep, sometimes there are legitimate cases for using these shut up TypeScript operations like an ascast. But anyway, moving back to VS Code, if we go to definition on this partial type, we can see all sorts of default types that come with TypeScript. This is this lib.whatever ES or ECMAScript version you're using, .d.ts file, and it comes with things like partial and required and read-only. So if you're ever curious about how to do some fun stuff in the type system, this is a great place to look. These are all the built-in types that come with TypeScript. And the one I want to talk about today is partial. This is what's called a mapped type. It takes an initial type, in this case t, and it gives back everything in t with some small change to it. So for every p in the key of t, by the way, these names are horrible, so I'm just gonna copy this here and call it my partial. And I'm gonna rename these things. So let's say that t is fine, but like, let's call p key, because it's really for every key in the key of t's. And you know what, it's still kind of unclear, so let's call it data. So given an initial piece of data, for every key in the data, then we give back the result of data under the key, but we add the question mark sign there, which calls something optional in the type system. So this is how partial works. We take in a thing and we say that it's all the same stuff under it, but optional. Ooh, I have syntax errors. Let me just get rid of those. Boop, boop, boop. Cool. So now when we call override defaults using our partial props, which is a my partial of props, we don't have to pass in all the things. TypeScript's still happy. TypeScript knows that emphasis is Boolean, but it doesn't have to be provided. So it can be, pardon me, true. Ooh, my syntax game is weak today. There we go. And if we want to pass another one, like sum or stuff, again, it doesn't have to be there, but it can be. Looks like the playground is freezing up on me. Refresh. Aha, stuff needed to be a string array. There we go. Okay. Maps types. Now these map types are really powerful things that we can use. Can you show a partial that only makes certain keys of a type optional? Yes. In fact, there's a great other map type we can use for that called the pick type. From T, pick a set of properties. Great question, thank you. This is fun. Pick a set of properties whose keys are in the union K. My pick takes in T, and I even like the name shape more than data. And for each key, or pick key, for each pick key in the key of shape, for each key in that pick key, we kept the result under shape of key. So type just emphasis and stuff is my pick of props, emphasis, or stuff. This is, I think, the point where people stop saying, oh, that's like basic rudimentary TypeScript operations, and start thinking, wow, this is some weird vulgarity here. We're combining several of the concepts so far, where in this version of my pick, or rather this usage of it, the pick key is either emphasis or stuff. So it's those two possible strings in the type system. And we're saying for each string in this pick key, so for both emphasis and stuff, the result is just shape of key. So this is not exactly what you asked, but it's part of the way there. Just emphasis and stuff is emphasis and stuff. We can make this combined with the original thing. So let's say that we have type the rest equals, and I believe there's another one, exclude. No. Okay, so the rest is my pick of props. What's the rest of the stuff? Let's say that we wanted omit. Thank you, Hendrik. Haha. Omit props, emphasis, or stuff. So omit is the opposite. There's omit in this file. There we go. Ha. Omit is another fancy thing. Given a T and a K, we pick the exclude of T and K, where what we're saying here is we get rid of all the keys that are matchable to the K. Cool. So omit is the opposite of pick. Thank you. So now we have the rest, which is text, sum, and other. So now we have type the rest partial equals partial the rest. So here we have these ones are required, emphasis and stuff, and we have these ones are optional, all of them. So we say type only sum required equals an intersection or both type of these two things. Or an intersection type is saying, I want both of these in my type. So only sum required finally says we are both the pick of emphasis and stuff and a partial of text and some other things. So now if we say, let's say fancy override default takes in sum required, we have to call it with emphasis provided. Otherwise, TypeScript says property stuff is missing in your thing, but is required. Let's give stuff ABC. And then now optionally, we can pass in whatever other things there were, which is, let's say, text. 1, 2, 3. Thank you, audience member, for helping me on this one. All right, so we've gone fancy. This is a combination of our union types, of a new type that are intersection types, and match types. Cool beans. Oh, yes, totally. To get to this lib es5 ets file, it's not possible in the TypeScript playground. I think trying to navigate to it is what crashed the playground for me earlier. But if you have some TypeScript source file open, I just made a new file here and selected language mode to TypeScript. If you start typing in the types, and then right click and go to definition, it'll bring you to this thing, which is this really long fancy path, but is available in all your TypeScript projects. Cool. An advanced question from the audience. Is there a way to do something like omit fields that start with something? In the nightlies, there is, and the newest versions of TypeScript, we'll have to play with it a little bit. The question kind of boils down to, can you do string operations in the type system? Yes, and we're actually going to build up to it. As to whether we can do the thing you're asking, I'm not entirely sure yet. It's a good question. But in order to understand string operations in the type system, we first have to understand, pardon me, we first have to understand inferred types. Let's say that you wanted to write a type called first param of, which takes in another type and returns the first parameter of that type. It's like if you had type my thing equals first param of, and let's say you wanted this to be string. You would have to write some sort of inference logic here where we take in the sum function and we check whether the sum function extends from infer first param any, and if so, first param, and if not, it's the never type. So let's talk about this. I think my syntax is off. Please hold. I'm cheating a little bit. I have these things pre-written out somewhere. All right, so let's go over this. This is an advanced form of what's called a conditional type, which is introducing logic into the type system. I think is actually a really powerful concept. This first param of takes in a t and it asks the type system, for this t, is it a form of this function? Is it a function that takes in some inferred first parameter type and returns, I don't really care, it can return anything. If so, then the resultant type for this t is that first param. If not, never. We can do a simpler version of this conditional type to rehearse before we really want to use this one, where we say type fit flip t equals t extends 0, if so 1, otherwise 0, where type flip 0 equals bit flip 0 gives us a result back of 1. So just to confirm, a conditional type is a type that takes in another type and then prints out or returns out a different type. Where in this case, if the original type is 0, we return 1. Otherwise, if the original type is, let's say, 1, we return 0. Is the 1 a type 1 or 1 number? This is like 1 string or 1 number. This is the type 1 number. We could do something like a bit flip to string, which would have the number equivalent there. But by default, no strings, therefore, or no string apostrophes, therefore not a string. Oops. Cool. So a conditional type takes in a type and then returns back out another type. In this case, we can add this inference logic to those types where we say, if the t extends from this whole thing, which is a function type that takes in an argument and returns anything, and we want to extract or infer out that first param, we can then put the keyword infer there to create this new type in our type system. Therefore, my thing, or my first param is probably a better name for it, my first param is string, because first param of this thing can infer that the first param is of type string there. Cool. This might be useful because you might, let's say, create a my call, which takes in a, I don't know, a callback t and a single param, which is a first param of t. And let's say you want to return a function that calls callback with single param. Cool. And now you might add something called an extends in the type system, which is only coincidentally the same keyword as this, but you might say that this extends input any void. Where in this particular generic, we are saying that my call function takes in the t type, or let's call that a callback type, because that's a nicer name for it. It takes in a callback type, which must be anything like this or more specific, where this is a function that takes in an input and returns nothing. And then we say that the single parameter is that first parameter of the function. So if we do my call, which is something that takes in an input number, and then pass it 1, 2, 3, then my call can infer that the type there, the callback type, is input number, and then the single parameter must be number. And if we mess this up, if we pass in ABC 1, 2, 3 instead, then my call is upset with us because TypeScript could infer the type was supposed to be number, but it actually was string of ABC 1, 2, 3. I think this stuff is fun. I don't know. It's not often that you get to use these types of cute little things in the type system because most code really doesn't need this level of absurd fanciness. But once in a while you get to do it, and it's pretty sweet. Someone asked earlier, can we do string operations and then some specific strings like a pick where you check whether something starts with a particular prefix? Let's do that. Template literal types. Let's say that you wanted to make a function like called use, kind of like how Express or other API handlers do things, where we have an input or like a URI route and a handler. And let's say the way you're supposed to call use is with calling, I don't know, like /user /ID, and then this thing takes in the ID. I did a shortcut by accident. All right. So that's a pretty standard way to make a simplified Express or COA or similar handler. So in your type system, you might say that URI is a function, or pardon me, URI is a string, and then handler is a function that takes in like an ID string. Or maybe this is like a more general use case. You do like args any, which means that it's any number of arguments. But this isn't super precise because, again, we want to specifically say that the ID is a particular string type, and this ID might get parsed out. So let's say that we have a type extract param name, or extracts, pardon me, param from, which takes in a t, which must be a string, and checks. If this t, actually, stop myself here, let's use a good name for it. If URI extends, let's say infer prefix / ID, just to start, then it's a string, otherwise never. What we've introduced here is, despite my computer lagging somewhat poorly, is an inferred template literal type, which is only available in TypeScript versions 4.1 onwards. So if you're working on the default 4.0, you're going to want to switch this to the nightly. Here we're checking in the type system whether the URI matches a particular string shape. And if it does match the string shape with this inferred prefix, then it's a string, otherwise never. So if we do type my fancy results equals extract param from / user / ID, then the my fancy result is a string. We can make this more complex by taking a look at the actual name of it. So let's say that we might infer param and return down the param type, which needs to be inferred, my param name. So now my param name here is ID. Now this, if you're a TypeScript user from previous versions of TypeScript, this is freaking mind-blowing, that you can take in a type, a string, and you can extract things from that string type in the type system. At first, I thought this was completely useless and silly, but actually there are a bajillion absurd reasons why you would want to do such a thing. One of them is this express route, because we might be able to say that like type creates handler shape for, where the URI extends string is, well, let's say that we have the param type. If so, then we have a, let's say a record, which I'll go over soon, record of param string, otherwise never, or otherwise the empty object type. This record type is a built-in one that says for each key in the provided keys, then the result is one of those. Let's say my record. So like type basic record equals record string number. This might say that you have an object where all strings are all keys are strings and all values are numbers. Now we can say, using this record type and this inferred string type, that the result here of type by ID handler param is the handler shape for / user / ID. And here, if I've done everything correctly and I'm not unlucky, then hooray, the param is ID string, which means that we can do what actually Express and other handlers tend to do, which is say that the params are a particular type. Params, cool. And then we can say that T extends, or the URI type here extends string, which means in this function, our URI isn't just a string, it's a very specific type. And then the handler takes in a single arg, which is of type create handler shape for the URI, which means now we know that here, the ID, finally, we've actually gotten to the whole thing we were trying to do. The ID is type string. Ta-da. I think this is hard to understand at first, so I'm just gonna wait until 1 o'clock, at which point my time will be approximately up, for y'all to just stare at this. But please let me know if you have any questions or would like to ask for clarification in the Zoom chat. Ooh, good question. What does TypeScript do in the background for the template literal? Is it some sort of regular expression? It is not a regular expression that I know of. However, I'm not super familiar with the TypeScript implementation here. I believe it is pure string matching, just like dot starts with equivalent logic, or dot ends with. However, if you wanted to, you could check the TypeScript pull request that added it. It's a relatively recent one. They did add a few fun operations in the type system around these strings, like an uppercase and a lowercase, which they then like changed a little bit after release. So it's still a little bit in flux. But yes, people have been asking for years, oh, can we have regular expressions in the type system? And they're not up to that level yet. So you can't do like repeating number characters. They get pretty complex rather quickly. But you can do starts with and ends with this type of thing. One fun little complexity here is I'm giving a talk at TSConf 2020 on Friday. If you haven't gotten your tickets yet, I would recommend. It goes over some of the same stuff here. Let's say that you have a type tic-tac-toe board, which is K row in 0 or 1 or 2, call in 0 or 1 or 2. Ooh, I missed the 1. That's a cell, or the cell, is a blank space, or an X, or an O. If you've never played tic-tac-toe, it's a 3x3 board where people alternate placing a piece to try to get 3 in a row, kind of like a very simple version of Connect 4. Great game. You could, in theory, write out a type parse move, which takes in a string, extend, and checks whether it's a like infer, let's say like a player extends X or O. You check like whether the it starts with a player and the space, and then infer row, space, infer call. If so, it's row call, otherwise never. So like a parse move called on, let's say like X at 0, 1 for the player X would give you the my move of 0 and 1. This in particular isn't super useful, but I think it's fun. So as a take-home challenge, I would highly encourage you try to figure out whether you can take in a like full-on game board that takes in a full template literal string with moves like X0, 1, X1, 1, 0, 2, 2, stuff like that, and figure out, can you turn this into a list of players with their moves? This is not something I'm going to go over now, but is something that I think would be a fun take-home assignment for you if you really want to play around with it. Cool. This is all I would like to go over today. I think we started off simple, got medium advanced, and then got a little more ridiculous towards the end. I'm not sure how to do a partial that checks for keys that start with a prefix, so I think that would be a fun little advantage type take-home exercise for you. But thanks for having me. I appreciate talking to you all, and thank you for listening. Thanks, George.
Nice. Thank you very much. Fancy indeed. And I don't know, personally, I definitely need some time for some of this to sink in a bit. Yeah, very fancy, very nice. It was a pleasure having you here. I really enjoyed it personally, and you never know, when this thing is over, you are most welcome to visit Munich. I will be your personal guide around. I mean, that would be really, really cool. And then we can have a real life meetup or something. Perfect. Anybody, any questions before we go?
No? I have a question.
Yes, please.
Josh, yeah, thanks for the presentation. So you were very quick. It's very informative. Yeah, how did you get to your level now of TypeScript? Did you just play around with it because these examples you were giving said aren't particularly so useful, or not that they're not useful, but you don't see them practically?
Mostly. I think the question was, how did I get to where I am now? These examples pretty much are cool, but not super common.
Yeah.
Yeah. If you do TypeScript long enough, although the examples or these types of fancy operations aren't super common, they will eventually be something you hit. I think if you do it long enough, you'll eventually get to them. Personally, I just really enjoy TypeScript. I think the type system is a really fun thing to play around in, and it's been fun watching it over the years grow from very simple things to having type narrowing, to conditional, to mapped, to inferred, to template literal types. Actually, thank you, Pascal, for mentioning this in the Zoom chat. Type Challenges is a fantastic repository. It's kind of like brain games, but for TypeScript type system things, where they have these little type challenges that you have to satisfy in the type system that start simple and then get complex. So if you're looking for a way to really strength up in these types of things, I'd highly recommend that one. Does that answer your question? Is that the info you were looking for?
Yeah, my internet connection is actually not too good right now, but I understood most of what you said. I'll check out this type challenges then.
Cool.
And I would agree, yeah, basically from playing around, I mean, you're in a project and not necessarily over engineering, but perhaps you want to try something different with the type system, and then you kind of try out the different methods that TypeScript offers. I think that's, yeah, how you get better with it.
Yeah, well, I think when you love something, it becomes your hobby, not just your job. So eventually you reach a high level of expertise. I mean, you're all the time doing that, so it sort of comes natural. Question from Josh already. Okay. Yeah. Okay. So I think if there is nothing else, we can slowly wrap things up. I will wait a couple of days. If anyone has any objection about me publishing this meetup, this talk to YouTube, please feel free to send me a message. You already know how to find me through the meetup.com, or you can find me from Twitter, my Twitter account. I think we can say, at least here in Munich, good night. I don't know, good evening. I don't know what time is.
It's bedtime. It's early, man.
Okay, yeah, perfect, super. By the way, everyone, I'm planning to announce the next meetup probably in a couple of weeks. So we'll see you again, hopefully. Ciao, bye.
All right, thank you. Ciao.